Thanks so much, and thanks for joining this session. So, yeah, we're going to be talking about threat modeling with a really fun Star Wars twist. Hopefully, there's going to be something new for folks if you haven't done threat modeling before. Maybe you'll learn something if you're a seasoned threat model. And yeah, let's just jump into it. So I just went to the next slide. Can I get a audio confirmation that you guys see that I transitioned okay? Okay, I'll assume that you can see my screen. Awesome. So a little bit about me before we jump into it. So I'm Audrey Long. I'm a senior security software engineer at Microsoft. I am in this organization called Industry Solutions Engineering, and I am a security and identity subject matter expert for Azure. So I do basically so many different things in my job title. I do architecture, I write code, I do tons and tons of threat modeling, and I love to do it. Aside from my professional life, I got my master's in cybersecurity from the Johns Hopkins University, and I'm a really big nerd. I love to play PC games, so if you guys also like PC games or interesting fantasy books, some of my favorite books are the Jim Butcher Dresden Files series. Love basically anything that is interesting and funny and sci-fi related. Also, big fan of hiking and doing lots of outdoorsy activities. All right. So today we're going to have a really awesome deep dive session over the wonderful world of threat modeling. So hopefully we'll leave today's talk with new perspectives and learnings. And by the end of the session, I'm trying to achieve a few things here. If this is new to you, like trying to achieve something called a security mindset. In one moment, sorry, of course, this turned off. Try to gain a security mindset, gain some threat modeling fundamentals, and we'll walk through some steps to generate some threat models on your own. And we're going to go through a really fun exercise of threat modeling the Death Star and gain some really cool and fun nerdy knowledge along the way. All right, so let's kind of jump into what is threat modeling? So really, threat modeling works to identify, communicate, and understand threats and mitigations within the context of protecting something of value. A threat model is a structured representation of all of the information that affects the security of an application or a system. And in essence, it's a view of the system and its environment through the lens of security. Threat modeling can be applied to a wide variety of things, including software, applications, systems, networks, distributed systems, Internet of Things devices, business processes, your refrigerator, literally anything can be threat modeled. Now, I get this question a lot, who should be threat modeling? And the answer to that is honestly anyone with a working knowledge of the system can do threat models. So that includes, your software engineers, security architects, your program and technical program managers, software testers. Basically, if you understand the system that's being built, you can do a threat model. And this is one thing that I really try to drive home in my organization is trying to get folks really interested and really getting involved in that threat modeling process too. All right. That's when it's easiest to make changes. It's less costly than adding mitigations and testing them after your solution's already been implemented. And when you create threat models, whenever you design new systems, you can also create threat models when you're existing or updating existing systems. Some examples include creating new Azure microservices or cloud applications, designing a public API to provide customers access to your data, a new feature to an existing application, and creating a new cloud infrastructure project. But those are just some examples. Really, the list goes on and on. All right, so before we dive into threat modeling fundamentals, let's discuss at a really high level what a security foundation here really looks like. So defense in depth is a strategy that leverages multiple security measures to protect an organization's assets. The thinking is that if one line of defense is compromised, another layer exists as a backup to ensure that threats are stopped along the way. Defense in depth addresses the security vulnerabilities inherent not only to the hardware and software, but also with people. as negligence or human error are often the cause of a security breach. Today's cyber threats are rapidly growing in scale and in sophistication. Defense in depth is a comprehensive approach that really employs a combination of advanced security tools to protect an organization's endpoints, data, applications, and networks. The goal is to stop cyber threats before they happen, but a solid defense in depth strategy also thwarts an attack that is already underway, preventing additional damage from taking place. And what's really the difference here between defense in depth and layered security? Well, layered security often leverages multiple security products to address only one security aspect, such as detecting intrusions or email filtering, while defense in depth is broader and more strategic in scope. Defense in depth really incorporates all of the organization's security measures to address all issues related to endpoint application and network security. To put it another way, layered security is one aspect of security, while defense in depth is a comprehensive strategic plan. Defense in depth covers more than just handling an attack, and it presumes a predictive, broader, and more varied view of defense. All right, now that we have some of the basics out of the way, let's talk a little bit more about what does the security development lifecycle look like here at Microsoft. So really any team that works in Microsoft, really on the Azure side, is where I'm getting a lot of this information from as well. All teams that deploy code must follow the Microsoft Security Development Lifecycle. It's also known as the SDL. There's a lot of documentation out there on how Microsoft likes to go over and implement the SDL and the best practices and things that we find along the way. Microsoft has also just introduced a new process called the SFI, or Secure Future Initiative, which also encapsulates a lot of this SDL strategy. And this applies to really any system or code that's available to customers that are using services, like, for example, anything that's within the cloud or as a part of Azure, or part of Microsoft, or part of Office, or deployed in any kind of manner here. And this also, we try to follow the SDL as well for test code, because that could also access production resources behind that, which customers can also get access to. So let's talk really briefly here, like, what is the Microsoft SDL practices? So it consists of practices that support security assurance and compliance requirements. And the SDL helps developers build more secure software by reducing the number of severity and vulnerabilities in software while reducing development cost. And it's really as a process there to help developers get instilled with security processes from the beginning, from code to dev to pipeline to deployment to testing, and so on, so forth. So let's kind of go through at a really high level. The first one, provide training, ensure everybody on the teams understands the security best practices. And then the second one is to define security requirements, to continually update security requirements to reflect changes in the functionality, to the regulatory, and to the threat landscape. Define metrics and compliance reporting to identify acceptable levels of security quality and how engineering teams should be held accountable. Perform threat modeling, and that's something we're going to actually dive a little bit deeper here into this presentation. Establish some of those design requirements, define and use cryptographic standards. So that's basically ensuring that everything that we're building has the latest and greatest crypto standards. We like to use NIST, FIPS as our compliance standards here because, we want to make sure that everything we build has like great encryption and whatnot. Also, using some of those approved tools, we have those lists to show what people can and cannot, download into their machines, their dev containers and whatnot. And we like to also harp on using static code analysis, dynamic analysis, doing some pen testing, and now in the age of AI, doing some of those red teaming activities that some folks might have heard about recently. But really the list goes on here around some of the things that we want folks to do and use, OSS scanning, SBOMs, that's another big thing that's happening, some of those dependency scanning. And last but not least, like, establish that standard incident response process. Just making sure that we understand what we're going to do, both in the operational phase and what happens like when incidents that occur. All right, so jumping on, we're going to be talking a little bit about the security mindset. So security requires a particular mindset, right? Good security professionals, we just see the world differently. We can't walk into a store without noticing how maybe we can shoplift, can't use a computer without wondering about the security vulnerabilities, can't vote without really trying to figure out how we can vote twice. We can't help it. It's just the kind of mindset that we have as security engineers. However, this kind of thinking is really not natural for most people. It's not natural for engineers. Good engineering involves thinking about how things can be made to work, and the security mindset is really there to help folks think about how things can be made to fail. It involves thinking like an adversary. You don't have to exploit the vulnerabilities that you find, but if you don't see the world that way, you'll never notice most security problems and you won't make good threat models. So by adopting a security mindset, you really emphasize the attacker, their motives, and all the ways that they can wreak havoc in your system. This approach, it really looks at all entry points in the system and all the weaknesses, and allows you really to focus on some of those critical assets that hold that highly confidential data for your system and figure out how to discover some of those weaknesses. So a security mindset, I would probably say, is one of the most important things that you can employ in order to help you create some great threat models. And that's one thing I always tell my software engineers that I work with too, that this is a mindset you need to adopt to really understand and see your system with a different lens. All right, so adversarial threat modeling. Let's talk about that for a little bit. So adversarial models, they really help us understand which types of bad actors will compromise the system and their typical budgets that are associated with them as well. And that does matter because with enough time and enough money, the adversary will always win. So we must first understand who would want to compromise our systems and select which adversary models to use when we're actually doing some of these risk assessments. Because then we'll really understand their means, their motives, their opportunities for real adversaries to really come in and damage the mission. To gain this understanding, cybersecurity engineers, they can really go and study historical attacks against similar organizations and systems. Now, this is definitely not what I'm going to be talking about today, but I really wanted to show folks like what threat modeling traditionally looks like for government efforts where safety, mission, impact is really greatly measured. So this is how we really traditionally threat model systems within the application security space, which is where I'm at now over in Microsoft. However, methodologies, techniques, learnings can really be directly applied with how threat modeling works in today's threat landscape and how we do it with missions that have safety and a lot of regulation involved. So this is what a 1,000-foot perspective of a threat model looks like. Now let's go to something that's maybe a little bit easier to digest. Here we can see the real core algorithm for what developing threat models within the commercial industry with a condensed version of the classical model, what I see a lot of people do in Azure and in Microsoft. These are the phases of threat modeling that a lot of people will snap to. So really either approach, and I would even say methodologies from either approach of threat modeling together, combined, separated, that is really up to the person that's creating the threat model. And I can tell you, I do stick to this pretty regularly, but I will go into the more classical version of threat modeling, and I will do attack trees depending on the scenario and what the customer needs. All right, so let's actually kind of jump into this. We'll go through it by one component at a time, and then we're going to take all the learnings that we have here and then go threat model something fun. We're going to go threat model the Death Star in a little bit. So here is what we're going to be calling the design phase. And this is really the starting ground for all your threat modeling activities. This is where you're going to gather as much data as possible about what you're building, what you're using to build it with, get all of those requirements in front of you, and really identify some of those key stakeholders that's really going to help you achieve a great threat model. In this stage, what we were trying to really get after is having all the relevant information here. So we know when we're creating those threat models, we want to know what is the system currently like. That way we can understand and figure out some of those threats and then create some of those mitigation strategies. All right, so step 2 is to design a data flow diagram. So DFD is a visual representation of a process or a system flow of information. By mapping out your processes, your system flows of data, DFDs will really help you better understand your process or your system, uncover its kinks, improve it, and can even help you implement a new process or a system. I would say whenever I'm teaching people how to do threat models, I really put emphasis on them understanding how to actually create those data flow diagrams. And I have a really interesting table that I like to pair with data flow diagrams too, what I like to call like a data flow diagram attributes table. And in the table, whenever we see a mapping, like for service to service communication, let's understand for each of the flows, like what is happening, what's the protocol that you're using, what's the auth end story, what's the auth z story. And that's where you'll really start to tease and find a lot of those threats, because whether we like it or not, development's difficult, and a lot of folks will take shortcuts when it comes to authenticating to services. A lot of folks will use those connection strings and some passwords, and we're like, no, like let's have a better understanding here on how we can make this better. All right, so data flow diagrams, this might be new, this might be something that you folks already know, but they're made up of shapes that create graphical representations of your system. Each shape represents a unique function, and each interaction is analyzed to help you identify potential threats and ways to reduce risk. So using these shapes in your diagrams, the way that literally everyone else in the world uses them is also like really important. It's something to teach your colleagues, folks that are doing threat models, because this is a pretty universal understanding here on what entities look like when we're actually creating some of those threat models. So it's not super hard to actually pick up a threat model and give it to someone else who's a security engineer in a different organization, and they could look at your threat model and totally understand what it is you've built there. All right, so number 3 here is identify threats. So this is the phase when you use the data flow diagram to find potential threats against your system, along with like data flow diagrams, data flow attributes, and use the threat modeling framework to really help you find the most common threats and ways to protect against them. A threat modeling framework is essentially a set of rules and guidance associated around teasing out threats within a system environment. And threat modeling is a great way to teach you and help you to find those threats and early on in that development lifecycle. And choosing the right focused approach here is going to help you tailor the threat modeling exercise. You'll find more actionable threats and ways to solve them. So Microsoft traditionally uses Stride. We'll get into Stride later when we go and do some of our other threat models. But there's so many different frameworks out there, and it depends on the project that you're working on which one you choose. So let's jump into a few common frameworks that I use a lot within my organization, which reminding you is in the cloud application space. So OWASP Top 10. This is one of the most famous frameworks, and I love to use the OWASP Top 10. And now that AI is becoming more prevalent, the AI LLM Top 10 has been absolutely key for me to create some of those AI threat models. So what I really want to stress the importance of here is that the Top 10 and the LLM 10, they go hand in hand. Because what I see a lot is actually folks trying to opt for one or the other. But I always take them a step back, like, no, we actually should look at both, especially since we're creating some applications for people to be using these AI, services and whatnot. Having both in here is actually going to be really important to understand. So those are really common frameworks that I'm using right now, as well as Stride. Stride is the threat modeling framework that's designed by Microsoft, and it's focused on the potential impacts of different threats in the system, such as spoofing, tampering, repudiation, information disclosure, denial of service, and escalation of privilege. By considering these potential impacts or goals and considering how they could be achieved, it's possible to really identify attack vectors for the system under test and under stress and under production. And based on that information, it's possible to assess the risks and impact of each potential threat and develop countermeasures to mitigate against them. And I also use the MITRE ATT&CK framework pretty frequently as well. because that's like the federally funded research and development center from the US government. And it is one of the areas of research in cybersecurity to create this amazing framework. And a lot of the customers that I actually also work with are in the government space, and they like to use, MITRE ATT&CK. So it really depends on what you're building and what kind of framework to use. And I would absolutely advocate for using more than one. Alrighty, 1 second. Okay, so here you can see is a really accurate map of like what stride elements actually map to some of those DFD elements. I like to look at this periodically whenever I am creating my threat models, because I think that it's really nice to just kind of have like a double check when you look at the flows that you're seeing within your data flow diagrams and seeing like, am I actually like achieving some of these stride categories as well? You can also, there's similar mappings out there for some of the other frameworks too, but I think that this one's a good reminder. All right, so number 4 here is, this is the phase, essentially where all the threats are decided. Each threat modeling framework should map to a security control within your environment, which offer different functions and types to choose from. We like to use in Microsoft this framework called the Microsoft Cloud Security Benchmark, MCSB. It also is created with a lot of great frameworks like NIST and whatnot in mind. So that's one that I use near and dear to my heart because I work a lot in Azure. Depending on what you guys use, there's tons and tons of ways to create these mitigation strategies out there and map them towards what you need in your companies. And last but not least, the verify phase is the last step of the threat modeling process that I wanted to discuss here. This is happening before like hopefully any of the systems and whatnot also get deployed. Ensuring that our dev crews and our dev teams are continuously going back and updating these threat models is also really important. Threat modeling is not just a one and done activity. It needs to be, included really in your DevOps lifecycle. This is an artifact that should not go stale. What I've done and what I've learned from doing these with a lot of engineers is if we actually take these threat models and check them into like some of the repos that they're actually working out of, they won't forget about them. And a lot of times, like if you use tools that they have access to, like for example, like Draw.io, where if you have like a lot of your diagrams already saved in there, you can check that into GitHub as well. So, there's lots of ways that folks can also integrate this into their processes to make sure that folks in the dev teams are continuously iterating and verifying and updating those threat models because it's really important. All right, so at a high level, this was also the security strategy that we just kind of briefly talked about. In terms of threat modeling, we like to go back and, map it all out, right? So going in there, identifying some of those key security stakeholders, evaluating some of those requirements and that architecture, generating those data flow diagrams for any kind of user machine flows that are going in and out of our system, generating some of those mitigation strategies with the frameworks that we've discussed, and creating some of those security backlog items from some threat model mitigations. All right, now let's get into the fun part. So you can threat model anything. And for the rest of this talk, we're actually going to get super nerdy here, and we're going to talk about threat modeling the Death Star. So using that algorithm that we just talked about, let's actually go deep here. Let's use that algorithm and start to figure out what information do we need here to actually go in and do a threat model on the Death Star. So according to the US government, and no, really, the US government actually like priced this out, the first Death Star would have cost around 852 quadrillion US dollars to construct. The Death Star also took around 20 years to be built because of its sheer size and complexity. The Death Star is a very complicated piece of machinery which contains very intricate services which rely on each other to achieve total destruction and induce fear throughout the galaxy. The Death Star's main purpose is to function as a mobile platform for its main weapon, the super laser. The Death Star's structure is basically an enormous housing for the super laser and for the reactor that powers it. At a high level, the Death Star is made out of 4 major components. the battle station, the super laser, the propulsion system, and the hypermatter reactor that powers all these components. So just kind of briefly going through it because it's fun and we want to learn a little bit more about the DS-1 Orbital Battle Station, aka the first Death Star. So the battle station we know is a huge equilateral trench across the surface of the whole Death Star, and it splits it into two hemispheres. And the trench is what houses many of the Death Star's main systems, such as the landing base, the drive thrusters, the sensor arrays, the tractor beam systems, and thermal exhaust ports, which are an outlet for dissipating the excess heat produced by the large energy reactors that are used on board the Starship and the space station, or in a central, ground-based structures. It's used in a few places. The super laser. So this has a massive lens, and it's really built around a huge synthetic focusing crystal. The lens is also known as the eye, and it's surrounded by 8 trebuchet lasers. And the Death Star super laser derives power directly from the hypermatter reactor. And the laser that converts and focuses the full power of the reactor is being used to create the beams that actually go and cause mass destruction. There's the propulsion system, which is made up of a network of ion engines that use converters to transform reactor power into thrust. And the engine thrusters are primarily lined along the equator of the station. And last but not least, the hypermatter reactor. The greatest challenge in designing the Death Star actually was not creating a cannon big enough to fire a beam that can destroy a planet, nor was it creating a battle station the size of a small moon. But the greatest challenge was always powering a cannon big enough to fire a beam that can destroy a planet and moving a battle station the size of a small moon. And to answer both of these problems, it was solved with the invention of the hypermatter reactor. So that's fun, right? All right, now let's go into actually creating a data flow diagram for this. So here you can see the data flow diagram I've completed around the Death Star. The main inputs to the control to this massive star-destroying system are coming from the command station computer. And here, an operator can do the following tasks. An operator can align and fire the super laser at a desired location, causing ultimate destruction. They can remotely control the station's deflector shields to protect the battle station from incoming damage. Activate the tractor beams to pull in some of these spaceships potentially to be interrogated. And we can jump to warp speed. They also interact with the main systems, such as the hypermatter reactor, the propulsion system, the laser ion cannons, and the drive thrusters. All right, so now that we have our data flow diagram in place, let's kind of start to look and identify some of those threats, since we now know how the information is really flowing in, where is it coming from, and how does it actually go through all the other components within the Death Star. So here's something I've really coined as a threat map. And this is really just a high-level representation of an attack tree. And in classical threat modeling, attack trees are conceptual diagrams that really show the variety of ways in which something can go wrong and the reason why they might go wrong. So they typically have something called a goal node, and the goal node is basically what the threat is actually into the system, and all of the leaf nodes are different representations on how that goal node can actually be achieved. So essentially, in this type of a diagram, there's just a high-level representation of all of the goal nodes that an adversary really can do here to interrupt or have a threat involved with any of the systems. So some of these identified threats here in this picture include disabling the ion cannons and tractor beams, exploiting the vulnerability within the system to destroy the reactor, tampering with telemetry to mislead battle station readings, disabling the protective shield around the battle station, command and control of the battle station computer, jamming ship communications, and since we're in a fictional universe with space wizards about, being mind controlled by Jedi. That's also a threat. All right, so next step in this process is to create some of those mitigation strategies. And then this is where it's going to get really fun. So first and foremost, I wanted to share, this is some of the mitigations that are going to be created throughout this fictitious scenario. And we're going to talk about what this exploit is here in the Death Star, where Luke Skywalker is exploiting the thermal exhaust vent by launching torpedoes into the vent, impacting the core and triggering a catastrophic explosion from insider threat information that we've received from, some other folks. And this is really interesting because the mitigation here is potentially something like eliminating that 2-meter wide thermal exhaust port or safeguarding this exhaust vent with extra defenses and perimeters. And there is just a really fun, really fun and different ways you can think about creating some of these mitigation strategies. Now let's actually jump into using Stride to seeing how we can have a better understanding here on what Stride actually means, how we represent it, and what we can do here within this universe. So let's talk about spoofing, right? So spoofing is a property of authentication, and let's talk about what it actually means here. The Death Star's sophisticated security system, for example, could potentially be vulnerable to spoofing attacks. So intruders might be able to impersonate legitimate personnel to gain unauthorized access to those critical systems, causing havoc. And understanding these vulnerabilities allows us to design authentication mechanisms that prevent some of this unauthorized entry. In some examples, impersonating stormtroopers, we see that in almost every single Star Wars movie. There's always going to be some Jedi that is campaigning around as a stormtrooper or something that they're not. And, some of the mitigations here are to use authentication principles or for users or machines by enabling more robust, multiple identity mechanisms, like MFA. All right, now let's talk a little bit about tampering. So the immense size of the Death Star brings with it the challenge of ensuring the integrity of its components. So tampering threats could target critical systems or manipulate important data, leading to disastrous consequences. So implementing tamper-proof technologies and continuously integrating checks would be essential to mitigating a risk like this. Really fun in this example, Obi-Wan Kenobi is tampering with the tractor beam system to allow the Millennium Falcon to fly back into the sunset without being trapped by that tractor beam that's pulling them in from the Death Star. Some mitigation here to prevent maybe Obi-Wan from doing this could be, he's a Jedi, to be fair, and it could be to add some validation, potentially some credentials or codes to even have anyone have access to disabling this tractor beam, and guards around the machinery, also some observability practices here. All right, let's talk a little bit about repudiation. So in the realm of space warfare, ensuring non-repudiation is paramount. A potential threat lies in malicious actors denying their involvement in destructive activities, making it crucial to establish robust logging and auditing mechanisms to track actions and to maintain accountability. In this example, we have Han Solo saying there's a very dangerous reactor meltdown to try to diverge some of those stormtroopers that are looking for folks. And that is a really fun example of what repudiation actually looks like. And some of this mitigation involving around this repudiation would be to ensure proper observability is in place and tracking down some of those adversarial behaviors and logging those behaviors, and always consistently looking at them, identifying some of those, true positives and creating mitigations around that. I stands for information disclosure if we're going back to the Stride model, and the Death Star's, vast repository of sensitive information includes plans, defenses, and personnel data. They could all become a prime target for information disclosure threats. And proper access controls, data encryption, data compartmentalization can also help safeguard against some of these vulnerabilities. And as mentioned earlier, Jyn Erso, relying that critical Death Star information to the Rebel Alliance. That is one great example of how we saw the catastrophic destruction of the first Death Star and so forth. All right, D stands for denial of service. This is the Death Star's operational continuity as it's imperative for the Galactic Empire. However, maybe a DOS attack could disrupt its functions, rendering it vulnerable to other attacks. And employing load balancing, redundancy, and DOS mitigation techniques would be vital in ensuring uninterrupted operation here. In this kind of example, Chewie's jamming some of those TIE fighter channels for getting communications clearly to and from TIE fighters in the Death Star. And yeah, we already went through some of those mitigations there. And last but not least, but E here stands for escalation of privilege. So escalation of privilege is preventing unauthorized personnel from gaining unauthorized access to sensitive areas, and this is very crucial because elevation of privilege threats could enable attackers to manipulate the station's operations from within. Implementing the principle of least privilege and rigorous access controls can counteract these risks. In this example, and pretty much anytime you see R2D2, he's hacking into something because he's just a little hacker. But yeah, this example, he's hacking into some of the star system doors to open and extract information. Also, in an unfair universe, Jedi mind control tricks can also probably escalate privileges pretty easy. And then last but not least, continuously iterate and verify. The Death Star's vulnerabilities may be fictitious, but the lessons we draw from them are highly applicable to real-world security challenges. And by employing threat modeling, organizations can systemically identify potential threats and develop strategies to mitigate them, ultimately enhancing their security posture. As we walk through the Death Star's vulnerabilities through the lens of Microsoft Stride components, we're reminded the importance of proactive threat modeling. By understanding and addressing potential security risks in advance, we can bolster our defenses, protect our systems, and ensure the integrity of our technological advancements. May this talk serve as a reminder that even in the world of science fiction, there are valuable insights to be gained from the realm of cybersecurity in our own galaxy. So before I leave you guys, we also have learning materials here. There is a really great module out there in the Microsoft world called the Microsoft Security Development Lifecycle and the Microsoft Learn on threat modeling. I will say that it's good to a certain extent. Then they try to get you to use the Microsoft threat modeling tool at the end of it. And I have my own qualms about that. So I definitely am not, I don't give a +1 to the Microsoft Stride threat modeling tool. Instead, I like to do my threat models by hand. I think it's also a really interesting and fun exercise to do it that way. You get a lot more insights gleaned too, and you won't be relying a lot on some of those outputs that some tools like to give you. And last but not least, thank you to all the sponsors and hosts. It's been awesome, coming and being able to present to everybody here in the OWASP space, OWASP New Zealand. And thank you guys so much. I really appreciate it. And may the force be with you.